A lot of this to life with a real scenario. So it's a simplified scenario, but actually probably a pretty realistic one. So we're in steady state. So our data warehouse has been deployed. We're in normal operating mode, and the business comes along with a new requirement. They say, we want lifetime value, a minute since last order per customer, and we want it in production by tomorrow. And at this point, one thing invariably happens. The data team throw their hands up in the air and say, that's completely unreasonable. Why does the business always ask us for these stupid timelines? And we actually struggled with this quite a lot in the early days. Why does this disconnect exist? And we realized actually it's because the business didn't ask for this 10 years ago. Why does the business now think they're entitled to these sort of timelines when they weren't 10 years ago? And the answer is actually outside the data world, the rest of enterprise IT has trained business users that this is an acceptable time frame. It's reasonable to ask for something, and if it's important, you can get it live same day, next day. If you're a product manager on e-commerce and you suddenly realize actually it's a Super Bowl tomorrow and I need a special offer on crisps and beer, to be told, yeah, we'll get that in the Q4 release is completely meaningless. It either goes out today or it's not worth doing. So we've got a plan. We know roughly what we need to do. As I alluded to, the first thing I do is create a feature branch. That's the first thing we always do in software development is inside our code repository, we create a new feature branch, which is a complete copy of typically the master branch or whichever branch we're forking from. Before we do any development, we run this. So a pipeline is attached to a branch. This is all smart. So it says, okay, well, I'm inside a feature branch. Therefore, I don't try and do ingestion. Inside a feature branch, I go and do this masking process, the cloning and masking we talked about. So we clone the production data warehouse. Within a minute, that gives us a perfect copy of production. Nothing I can do in the sandbox can physically affect production. In fact, very often a developer themselves may not have access to the production. They may not have permissions for it. It'll be a system account that does that clone, but the developer will only see their own feature branches. So a developer may not even physically be able to see the production database. But that's fine. There's a system account that does the cloning, and then they get given access to the clone. So that's the first piece of environment management. Now I've got a feature branch of my code and effectively a feature branch of my data warehouse. That's the key piece. And we use a feature in Snowflake called zero copy clone. One of the reasons that Snowflake love this DataOps approach is because it highlights a bunch of features in Snowflake that are really, really powerful, but they require a lot of thought and infrastructure and plumbing around them to use. That's effectively what we've baked to the DataOps platform. So this is making use of a feature that Snowflake's had for 2 years, but very few people have used it. Okay, so now we've got an environment we can actually think about doing our development. And this isn't really a training course on how to write models, but our models are effectively templated SQL. Why? SQL, because it's pretty much the lowest common denominator. And actually what it does is significantly lower the technical skills needed to get into doing this. There are an awful lot of BAs who say, well, I would never dream of writing code. I would never dream of trying to create a talent job, but I can write basic SQL. Anybody who has the confidence and skill and has done a half a day of training who can write a bit of SQL can go in and do this. Doesn't mean they have to, but they can. And then with what we look at later, you can still have controls in place to say someone may have done it, but I want someone who's more experienced or more expert to peer review it before we go ahead and use it. But you'll notice there are some non-standard SQLs and things here. So that's the templating. And in this case, the templating is relatively straightforward. We'll see a more sophisticated example later. But essentially, we use templating to do a couple of things. We do it to pass metadata in. We do it to reflect the fact that we can't specify any sort of database name or table names. Remember, this model could be run 1 minute in the production data warehouse. The next minute, it could be run in a QA environment. The next minute, it could be run in a feature branch environment. So we can't hard code any of this. So these references that you see are basically, this is the way we join models together. So all of those arrows that I showed in that previous block diagram, each of those are basically just following a reference. A reference just says that it calls the model that you want to inherit from as part of the from statement. And then when we do the compilation step, it says, right, because I'm in this branch, because I'm running in this mode, it will work out the right database, the right schema and everything else. And that all just happens by magic. But broadly speaking, what we're doing is saying, this is a consumption model. I'm going to take the calculation model called fact sales order. I want to do something new, and the business wants a slightly different way of viewing the information. But when I looked at it, I said, well, almost all the work I need to do this, all of the joining of the sales order header and sales order detail and all of the processing, that's already been done for me. So I don't need to recreate this from scratch. What I need to do is say the user wants something that's very similar to the consumption fact sales order model with a few changes. So what I'll do is I won't write this from scratch. I'll duplicate that one, inherit the fact that it reads from the calculation fact sales order model, and I'll just make my changes. That piece is critical because we're not repeating anything, because we're inheriting means that when in 3 months' time someone realizes a bug in the sales order header curation model, they change that, they test it, it gets propagated all the way through, and everything that depends on that is updated. The SQL in here is actually pretty straightforward. I've said I'll have customer ID as customer ID. I'll do a diff between the max order date and the current time as minutes since last order. I will sum ignore the average. I'll ignore the sum as the total lifetime value from this sales order table and group by one, which is customer ID. So that's basically it. That's all I've really needed to do. At this point, I commit that, committed to my feature branch. I'll put a commit message in to describe what I've done, and that will automatically kick off a pipeline. This pipeline here is saying it will try and do a clone again. Now it's relatively intelligent. It says, well, I know a cloning takes a minute, but if my clone of production is only 10 minutes old, it's no point in repeating it. So it has a little timer. I think by default it's 10 hours. So it says if the clone is less than 10 hours old, don't even bother recreating the clone, just use the one I got. So that step will skip almost immediately. And then it will go through the compilation, the models, and then the execution of those models. One of the principles, and so if you want to get to agile development, one of the first principles, you've got to fail fast. There's no point in waiting 15 minutes to tell the user, oh, sorry, it broke. That was one of the reasons we compile all the models in advance. It just checks that the models are internally consistent, the references are all valid. And in fact, here, what we found is when I originally created this, I figured it, I got the wrong reference. That's fine. It tells me what I need to fix. I go in. So that's the first bit of testing. Even before I've tested against data, just testing that what I've written is valid and can be executed. I go around that loop, I fix that, I commit it, the pipeline runs again. Now the pipeline runs all the way through. This is great. I see all my results of all my stages. All of my source stack will be here. We'll be creating curation ingestion models. The business domains will be creating calculation and consumption models. Then I go through a data testing stage. All that's passed. And when I look at my documentation, I can see my new model has appeared here. And it inherits from the calculation fact sales order, as we talked about. When you want to do any sort of UAT, but it doesn't have to be UAT with a stakeholder, but just as a developer, I want to see the results of this. Ultimately, this is manifested in a completely standard Snowflake data warehouse. So I just go in and look at it in Snowflake. It's the easiest way to see it. This all looks broadly right, except my minutes that's last row is negative. Why? Because I'm not a very good developer. This is not my day job. I got my date diff terms the wrong way around. So I swap my date diff terms around. I do another commit. I run the pipeline again. I see the results. Now, the point here is I did a create a feature branch of my code, the initial build to create a feature branch of the database. The first time around this development loop, I had some errors where it wouldn't compile. I fixed those. The second time around that loop, the minutes were the wrong way around, or the date diff was the wrong way around. And now effectively on my fourth time around this loop, and in total elapsed time, maybe 10 minutes, 15 if I haven't been doing it very frequently, but if I'm doing this day in, day out, probably less than 5 minutes. We've gone from standing up an environment to work in to being on our third actual iteration of this in somewhere of the order of 5 to 15 minutes. I go and look at Snowflake, it looks good. These answers all look like what I'm expecting. Right, testing. We said before, I've probably already bored you with the stressing on testing, but it is absolutely so important. This is paying forward to your future self. The tests you write now, you and everyone else working on this project will benefit from for many years to come. One of the models we have with the DataOps platform is either a low-code or a no-code model. We've tried to avoid requiring complex coding. So in some cases where you can only do it with a language, we've used a low-code model like SQL, but actually in terms of testing, we've tried to make that completely configuration driven. All you need to do is basically how to create a config file or how to copy a config file. If we just decompose this file a little bit, the name is the name of the model I'm applying it to. The first test I'm applying is the minimum rows test. There's a lot of aspects of data that are harder or seem to be harder than conventional software CI/CD. They're actually not that much harder. It's just that this mature. We haven't been doing it for 20 years. There's actually one area where data is considerably easier in most cases, and that's testing. And the reason being is that generally with data, when things fail, when things break, they break big. If you think about a SQL join, you get a SQL join wrong, you're expecting it to return 1,000 rows. It typically doesn't return 1,010 rows or 999 rows. It returns no rows or 10 rows or 1,000,000 rows. And that's bad unless you're trying to write tests, in which case the fact that when it fails big is actually brilliant because it makes it much easier to write tests for. In this, just the simple fact that, okay, when I wrote this, we had 19,000 customers in the customer table. So, okay, we might lose a few here and there. But as an acid test, I would never expect to drop below 15,000. So if this table's got less than 15,000 rows, and it's a very, very quick test that we can say, okay, something's broken. So it's a schema level test. So that applies to the table. Then we can apply column level tests. So we say, okay, customer ID must be unique because we're asking for a result by customer. It must be not null. It's not valid for us to have null customer ID in here. Okay, total lifetime value. So I go and talk to my sales team and they say, well, one of our customers is never going to order more than 5 million with us over a lifetime value. So the value must be greater than 0. They can't be in here if they've ordered nothing. And let's say it'll be an error if it's over 5 million. Total lifetime value cannot be null, and the minutes since last order cannot be null. So these are all just relatively simple tests, but even those simple tests probably catches 95+% of things that are likely to break. And we've got a whole library of other test types that you can do here. This is just showing 3 of them. As a general rule, we would say almost even if you're prototyping, once you've done it a few times, if the workload to create tests is so low, just if it becomes muscle memory, I create a new model, I go and create a few tests for it. And once that becomes muscle memory, so many things in your life become easier. Before we push this to production, let's just validate with Stakeholder. And this, to some extent, touches on what you're talking about earlier. This is not my first rodeo. And I know the reality is I may have given the business what they asked for, but it's not necessarily what they want. And that's fine. The historical approach would be, that's terrible. There's something gone wrong here. How's our process broken? Our process hasn't broken. This is reality. It is unreasonable in most cases to expect a business user to give a perfect definition of what they want unless you've actually shown them some of it in practice. So the business users, what do they always say? Oh, you've given me what I asked for, but I've just realized I need average order size as well. Okay, great. Because we're embracing Agile, we love this. Change is good. We embrace change. We can afford to embrace change because embracing change costs us minutes, not days and weeks. So I go in, I add this average order value in, I commit, I run the pipeline, I go around the loop again. So now I've got my stakeholders happy. They've confirmed it's doing functionally what they want. My automated tests are passing. Now, as far as I'm concerned, this feature's ready to go. So that's just showing the results of the automated tests being executed as the ones that we just created. One of the most fundamental governance principles in all software development is it must take at least 2 pairs of eyes for anything to arrive in production. The data vault should be no different. Doesn't matter how good I am, doesn't matter how experienced I am. Everybody has bad days. Everybody gets distracted. Everybody can make mistakes. The best software developers I've ever worked with, the most senior ones, are the ones that will say, it doesn't matter. I'm perfectly happy to have the most junior person in the company peer review my code. In fact, in many ways, the most junior person is a great person to do peer reviews because they don't have any of the same preconceptions. They don't think about things the way I think about things. They're more likely to spot things I've overlooked. So we solved that the way that source control has done for many years. We don't just commit to master, we create a merge request. So we're requesting to move into a development branch or a master branch, but we're then assigning or asking other people to look at it. So in this case, I'm asking to push it into master. I write a little summary of what I did, why I did it. This will automatically attach all of the commits. It will automatically attach all of the pipeline runs, the test results. Everything automatically gets bundled up into this merge request and fired over to whoever I choose to assign it to. So this is now part of the release process. And the release process is really anchored around the concept of a merge request. This now comes into where it's been assigned to. They see all of the information. One of the really useful things here, it creates a merge request pipeline, which effectively is saying, up to now, you've had pipeline runs in the feature branch. Let's run a pipeline as close as possible to what it would be if and when it went into master. So this is giving the person approving it the best possible view on, if you accept this merge request and it goes into master, what will master look like? What tests will pass or fail, and so on. So it's giving them another run of a pipeline to give them the maximum possible information and confidence to approve this merge request or to push back. But a lot of what we're looking for in the merge request isn't just simple, hey, all the lights have gone green. The real value of a merge request is looking at the non-functional requirements. Hey, I see you've got one model, it's got 400 lines in. Can you break that down into 5 or 6 models and have them composable? Would be a very obvious one. We did a live demo with a customer the other day. One of our engineers did a merge request to me in the demo, and I did a live response back saying, hey, you just created a model with no automated test, rejecting the merge request, which I was a little bit embarrassed by, but actually I said, this is great because we're showing this is actually what would happen in production. If in reality, if you'd have submitted something to me for a merge request without test, I'd have bounced it back straight away and say, this may be the best model ever written by anybody, but without an automated test, you will never know if someone else in the future has broken it. So that's kind of the release process. Then, as we said, continuous deployment really doesn't exist in the data world yet, nor should it. What we would expect most customers to do is accumulate fully tested changes on master, and then at a point in time, in a maintenance window, maybe once a month, hopefully more like once a week, they deploy the last week's worth of tested and approved changes, and they do a redeploy to production. And that's the typical method we're seeing from most customers. Some customers are getting a little bit more ambitious, say, hey, we think we might be able to move to multiple times a week or maybe even move to daily. Then it moves into operate, and operate in this sense is really the actual business users interacting with the system, interacting with data, and we know what that looks like. And then the final step is monitor. And there is also some cleanup steps, because in the same way that I delete a feature branch when I'm done with it, I also don't want to leave that feature branch data warehouse kicking around. So I go and clean that up. One of the things that probably you'll be well aware of, but it's worth just touching on, is when it comes to governance and change control, I don't believe there is any way of getting a better visibility of who did what, when, where, and why than just standard Git processes. I can look at any file, I can look at any code, I can look at any configuration, I can say exactly who worked on every line of it, who worked on every character of it, when, what they were doing at the same time, when they committed that in, who did the merge request, what were the automated test results like, and I can do that on a line-by-line, character-by-character basis. I have essentially a complete and perfect lineage of everything that's ever changed. And I could also use that to revert back. So if I decide I don't like something, with a couple of clicks, I can say, okay, I want to just isolate this one change by this one user and revert it back, and then make sure all my tests pass, and then promote that. So the final thing I started to talk about is monitoring. If you talk to organizations that have been doing DevOps and Agile for a long time and have really embraced CI/CD, I use Netflix as an example of this. They're one of the poster children for doing this really well. What they say is they spend a lot of time on writing automated tests, but they also acknowledge that they're really fighting a losing battle. It is not possible to write perfect automated tests. It is not possible to get perfect test coverage. Really mature organizations acknowledge that. So rather than spending all of their testing resources, all the allocation of time writing tests, they say, okay, we'll spend about 70% of it writing automated tests to try and stop bad stuff getting to production. But we'll accept that to a degree, we're always just putting off the inevitable. We might put off a problem that would have occurred next week to next, and we'll slip through. Something we didn't think to write a test for, and something will slip through into production. So then monitoring of the system to try and say, okay, well, if something does slip through and we can't prevent that, the next best thing we can do is detect it very, very quickly and be able to respond to it very, very quickly, typically by just doing a rollback and revert. This is the area of the system we've probably done the least work on, but we've got some fairly useful, if simple things. So the one that's most standard for us is, let's just capture the row count of every table in every schema, in every database, and views as well. And we dump them into Datadog, which is our standard monitoring tool, and we get Datadog to do anomaly detection on it. What does that do? It says without any manual configuration rules or anything else, it will just notify me of any step changes. It doesn't tell me whether they're good or bad, but it learns the behavior. So let's say my customer acquisition, I'm growing by 100 customers a month, give or take, and suddenly my number of customers in a month jumps by 1,000. It will probably flag that and say, just want to let you know, your customer count has jumped significantly. Maybe fine. Maybe you just had a great special offer and you signed up 1,000 customers last month. Fantastic. If my customer count drops by 5,000, it will flag that and say, just letting you know that, not saying it's good or bad, but this looks like atypical behavior. So this effectively is allowing, using some off-the-shelf anomaly detection and machine learning to establish what over time our data warehouse looks like, what normal looks like, and then to flag when we get deviations from that. And there'll be a lot of monitoring. You can implement your own monitoring stuff. We'll be implementing more and more standing monitoring stuff over time. But this we found is a pretty good starting point for catching most stuff. Monitoring catches most of the stuff that automated test misses. Okay, so if I just kind of summarize there. So if we think back to this original, we think back to those 5 buckets that it seems like a long time ago now. I put the problems we're trying to solve into 5 buckets. One was speed of development. We want to be measuring tens of cycles per hour, not single-digit cycles per month or per fortnight. We want that development pace to be sustainable, and the next slide breaks that out a little bit. Maintainability. Yes, we're going to build complex systems. Anything that's modeled in 2,000 lines of stored procedure is a complex system. That's okay, but if that's the business reality, we can't get away from that. What we can do is build a complex system out of many small, easy to understand, easy to maintain, and easy to write tests for building blocks. We can build that with configuration over code wherever possible. And when we do have to use code, we use a low code that most people understand, like SQL. Testability, we've talked at great length about. Remember, when you're writing automated regression tests, you're not writing them for you. You're not writing them to test your feature. That may be a little bit of a byproduct, a benefit. You're writing them to make sure that the thousands of people and changes that come after you will not break your code. And if they do, they're notified about it and they have to change whatever they did that broke your stuff. Governance and change control, we've talked about a fair bit. Every change, every approval, test results are stored, auditable forever. And everything that's getting into production has been through multiple layers of automated testing and at least 2 pairs of eyes. That's a pretty robust level of governance and change control for most organizations. And then finally, if you put all this together, what do you get? Far higher availability. And remember, availability isn't uptime of the data warehouse. Availability is far higher percentage of time where when a business user is looking at the data, we know, or we're very, very highly confident that is good. Why? We've built it robust, we've built it repeatedly, we've built it automatically, so there's no possibility for manual errors here. And we've tested it extensively, both before we committed it, and then as we're deploying the pipeline with a whole raft of tests to make sure that if something does go bad, it doesn't make it to production, it gets stopped ahead of time. And finally, we have external monitoring in the rare case that something does slip through, they're able to catch it very quickly and roll back, very likely before any business user has noticed it.